So welcome to this first Comunica webinar, where the goal is to give you a very high-level introduction of everything around Comunica without also going into too much of the details. All right, but let me first start with sketching a bit of context. So as some of you are probably already aware, there are a lot of different ways to publish knowledge graphs on the web. So there's a lot of variety in the amount of APIs you can use to publish knowledge graphs. And related to that, there are different ways to access data through these knowledge graphs, so different access patterns you have to take into account. And related to that, each API may have different query languages that it supports. So yeah, there's a lot of variety in how you can publish knowledge graphs on the web. So for data publishers, this is a very good thing, of course. They have a lot of freedom in how they can publish knowledge graphs. But on the other hand, this variety leads to a lot of complexity for application developers. And they can have some difficulties with this variety on different levels. Like first thing is they need to be able to distinguish different APIs from each other. Like if they receive a URL to a certain API, the developer first needs to be able to determine what kind of API this is exactly. Then the second difficulty is they need to be able to determine how they can exactly interact with these APIs and how to do this in an efficient way as well. And next to that, there are also some cases where data may be spread over different APIs. So in that sense, application developers also need to be able to combine data across different APIs. And also they need to be able to do this in an efficient way. So yeah, there's a lot of difficulties here for application developers. And this is exactly where Comunica is positioned. So the goal of Comunica is basically to abstract access to knowledge graphs on the web. So the goal here is that it can hide all of the complexities for reading and writing for application developers. So in this figure here, you can see that Comunica is positioned between the application, the client-side application, and the knowledge graphs on the web. So it's this abstraction layer. Okay, so this was a bit of context. The rest of this presentation will be split up into three main parts. So in the first part, I'll just go over some of the fundamental concepts within Comunica that are important to understand. Then we'll have a look at how to get started with using Comunica. So I'll give you some live demos here. And then in the final part, I'll give you some pointers to some of the more advanced topics, but I won't go into too much detail about them. I just want you to know that they exist, and then you can find more information after this presentation. All right, so let's have a look at the fundamental concepts first. The first important concept is that of queries as abstraction layer. So I'm talking about queries such as Sparkle and GraphQL and so on. So these are declarative query languages that say what needs to happen, but not necessarily how it needs to happen. So through these declarative queries, you can basically hide all of the complexities for actual data retrieval at the data APIs. And another consequence of these queries being declarative is that the queries are reusable across different APIs because they are not tied to specific APIs. Now, since the queries are declarative, you still need a way of actually executing them. So converting them to executable code and so on, and retrieving query results. So for this, the goal is that we have a generic reusable query engine, such as Comunica, that can execute these queries and abstract away in that way the complexities for executing the queries. And a nice consequence of having this as abstraction layer is that, like, let's say, for example, the query engine updates to a new version, and within that version there is an optimization internally within the query engine that makes certain queries faster. If an application developer makes use of that query engine, and it just interacts with it through Sparkle queries, for instance, then it can, by merely updating to the new version of that query engine, it can immediately make use of those optimizations without having to change anything in the actual code. So yeah, queries as abstraction layer. A second important concept is that of heterogeneity and federation. So the goal of Comunica is that it's able to understand as much sources as possible. So the goal is that you can throw any URL at Comunica, and Comunica will try to query it as efficiently as possible. So at the moment, Comunica supports a bunch of different source types already. So it can query overlinked data documents, DPF interfaces, Sparkle endpoints, and so on. And secondly, is also important here is the concept of federation, where Comunica will also be able to combine multiple sources. In the case of data being spread over multiple sources, Comunica will also try to, as efficiently as possible, query over those different sources. And also relevant to mention here, something that we're currently working on still is source discovery. So in the case where your sources may not be known beforehand, in that case, Comunica in the future will also support discovery of sources that are relevant for the query. So this is useful in use cases where your data is massively decentralized, like in the solid environment, for instance. Okay, so heterogeneity and federation. Another important concept is that of flexibility and modularity. So you should kind of see Comunica as being a meta query engine. So Comunica is actually just a collection of building blocks, where each building block independently implements a very specific functionality. And then the idea is that you can combine multiple of these building blocks together to build a specific query engine with specific functionality. But of course, we have a bunch of presets available, so precompiled configurations such as Comunica Sparkle, which is a collection of these building blocks that just allow you to execute Sparkle queries according to the Sparkle specification. But you have some other presets available as well, such as the presets specifically for querying over solid pods and so on. But you can also create them yourself, of course. Okay, then one last important concept is that of openness. So Comunica is actually open on different levels. So first, it's based on open standards, which means that it implements open web standards such as Sparkle and RDF and so on. But it's also implemented using web standards. So the JavaScript stack, for instance, which means that it can run anywhere you want. So it can run client-side, it can run server-side via Node.js, and so on. And also important to mention is that Comunica also implements the RDF.js interfaces, which allows us to be interoperable with other TypeScript and JavaScript libraries that do something with RDF. Comunica is also fully open source under the MIT license, so you can basically use it for whatever you want. And then also important to mention is that of open governance. So Comunica is actually part of the Comunica Association, but I have another slide for that. So the goal of the Comunica Association is basically to connect companies to each other via a non-profit organization. So the goal of this association is basically so that different organizations that are interested in seeing Comunica sustainable in the long term, they can finance core maintenance to advance the roadmap, where the idea is also that the different organizations that are part of the Comunica Association, that they also can collectively determine what exactly the roadmap is. So next to this core maintenance, there's also a bounty program in the Comunica Association, where the idea is that organizations that, for example, run into a certain bug or have a feature request, that they can place a bounty on this issue, so that the association can try to find developers that are interested in resolving this bounty. And once they have resolved this bounty, they will get paid this this amount of money that that the organization has placed a bounty on. So in case anyone would be interested in this, feel free to contact me or learn more on the website. Okay, so those were the fundamental concepts. Before I go over to the next part with the live demos, are there any questions about the first things already? No. All right. So let's have a look at some live demos then. So the first thing we'll do is have a look at how to use Comunica on the command line. In case you would want to try this out yourself, make sure that you install Comunica Query Sparkle globally via NPM. So if you don't have NPM yet, this is also installed when you install the Node.js environment. So that's required to execute Comunica. So I won't execute this on my system because I already have it installed. But what we'll have a look at in just a minute is how to execute a Sparkle select query. And then we'll also have a look at how to execute a construct query. So all of the things I will show you are also explained in more detail on the website, in case you would want to have a look at it during your own time later. But okay, so let me open my terminal. I assume this is visible to everyone. So the basic CLI tool of Comunica is Comunica Sparkle. So if we execute it, you will see the help output here. So these are all the things you can do with it. So what we'll have a look at now is we'll just execute a very simple Sparkle select query on this dbpedia data source. So I'll just copy paste this command here. For simplicity, I'll make it a limit of 100, so that we'll have 100 results, and you'll see that we get some output in here. Now, this is just a custom JSON format that that Comunica serializes to. What you can actually do is you can change this this output as well. And in order to see what the output or the supported output formats are, you can do this list formats option. And you'll see a list of all the supported outputs here. So for example, if we would want to serialize to the like the official Sparkle JSON results format, we can do this here. So -t and then the format you want to serialize to. And you'll see that we get output according to the what the actual Sparkle standards prescribes. So there are some other output formats as well that are relevant. Like for example, if you just want to output to CSV, you can do this easily as well. So it's not very visible here, but this is all just CSV. Now, one other thing that is important to mention is that if you execute anything in Comunica, everything will happen in a streaming way. So if I remove this limit and I just request all of the triples of the dbpedia dataset, we'll see a lot of results coming in. So this is actually streamed live. So as soon as the Comunica query engine has produced the result, it will immediately be shown here. But I'll just stop this because this dataset is very large. So it will run for a while. But relevant to, sure.
Yeah, super quick question. It's just a minor thing. Actually came up literally yesterday. I was using Comunica and demoing it to a customer, the try live thing on the web. It's just when I show the data sets and I talk about DBpedia, I think the most recent one in the live demo is like from 2015. And I just noticed there it's whatever 2016 or what's going on with DBpedia? Are there no more recent data sets than 2016 or something?
Yeah, they have changed their release process a bit, but I actually think like this year or late last year they made an actual proper new release yet. But yeah, we should update our demos to reflect that as well, I guess.
Yeah, it just looked a bit strange, you know, to be like 7 years old or whatever. Was like, oh my God, I'm not using that. Anyway, no problem. Okay, there is a more recent one. That's good to know. So there'll be an update soon, perhaps. Yeah,
we should look into that. Okay, where was I? So so these streaming results. So actually, all of the output types also support streaming. So like if you serialize to CSV, you can also just do this without a limit, and this will produce a nice stream of CSV. So you can also just pipe this into a file, and you won't get any memory issues or anything like that. All right. Then I also wanted to show you how to do a construct query. So I'll just copy paste this here. So if you execute this query, in this case, we don't want to output like select results that produce like a table of results. We now want to produce actual RDF triples since we use a construct query. So by default, Comunica will serialize to trig. So this is like turtle, but with quad support. But again, you can change this via the list formats option. So for example, if we, let's say, want to serialize to JSON LD, this is also perfectly possible. And also in a streaming way, of course. So let me just do a construct of all of the triples in the data set for JSON LD. And if you do this, you will see a bunch of JSON LD being outputted. Okay.
Sorry, Ruben, maybe just a quick question there.
Yes.
So I assume in that case, what you just showed with JSON LD, like there's no at context in that output, is there?
No, indeed, that's without the context.
Yeah, because you can't predetermine what's going to be in the context, I presume, in the streaming fashion, right?
Yeah, indeed. So there are ways possible to serialize for a specific context or specific frame even, but this won't be possible in a streaming way, or at least not for all of the possible contexts or frames.
Okay. Yeah, no problem. That makes sense. Thanks.
Maybe one last thing I want to show you on the command line is, so I'll just copy paste my simple query here. In case you would want to know more information about what is actually happening internally a bit, you can enable the Comunica logger. So using the -L option, you can, for example, show the debug log output. So if you do this, you'll see, the results mixed in between the debug output. But let me just silence the standard output because the debug output is printed to standard error. So here you can see all of the debug outputs. So you'll see what we did here, or the Comunica query engine at least did here, is it did an HTTP request to this URL here. It did this with this long accept header, this user agent, the method, and so on. It actually did another request internally as well. So yeah, if you want to know what are the kind of requests that are being done when you execute a query, this is how you can do it, or one of the ways you can do it. Okay. Any more questions about the command line part? No. All right. Then we'll have a look at how to get started with using Comunica in an application. So for this, I'm going to assume that we have a like an NPM package installed already, and that we have added Comunica Sparkle as a dependency like this. So what we'll have a look at is how to instantiate a new query engine object and how to do a very simple select query on top of that. All right, so let me just open my editor here. So to get started, we just create a new engine. So this is query engine, and we just import it like this. So I'm just using plain JavaScript for now, so no TypeScript to keep things simple, but this will also just work in TypeScript. So in that case, you can also use the import syntax if you want. All right, so what we did here is we create a new instance of the Comunica query engine. If you decide to do multiple queries, it's important to reuse this query engine as much as possible because there can be caching happening or something like that. So if you can reuse this query engine. Okay, so let's have a look at how to execute a query. So if you type query, your editor will show you that there are multiple types of or variants of the query method. The one we want to use here for a select query is the query bindings method, because a select query will produce a stream of bindings objects. So this is the one we want to use. So let me just copy paste a very simple query from my other screen here. There we go. So this is just a select with limit 1. And the second argument of this method should always be the so-called context object. So this is an object in which we can pass additional information into the query engine. And the most important thing you want to add here is the sources you want to query over. And this is always an array. So what we'll do here is we'll just query over the same source that we used over the command line. So this DBpedia dataset. Okay, so the thing here that is returned is actually a bindings stream. So as I told you on the command line, Comunica always produces streams. So the result here is a bindings stream. And the thing is, we have to await this because this is an asynchronous method. And then one small detail, since we're using Node.js here, Node.js does not support top-level awaits. So we actually have to wrap this in an asynchronous function like this. So this is only needed if you if you execute it or execute queries like I'm doing here. Actually, within an application, this probably won't be necessary. Because then you're not working at the top level. Okay, but wrapping this like this is enough. So the simplest way of consuming results is also not the recommended way, but I'll just show you how to do it for testing, is converting this stream into an array. And again, we have to await this. So this results object will actually be an array of bindings. So if we print this, and I'll just print the length, you'll see that we just modify the query here so that we have a limit of 100. So if we execute this, you should see 100 being printed here as the length. Okay, so I just told you that this is not the recommended way of consuming the results, but it can be valuable for quick testing. Now, the reason why it's not the recommended way is because this line here, it will block your code execution until all of the results are available. So if we, for example, set this limit to 10,000, you'll see if we execute a code that it will take a while before it prints. A better way of working is to actually consume the stream in a streaming way. So if we want to do that, we just attach like any standard node stream a data listener. Then we can, for example, just print the bindings object. Now, very important, if you use any node stream, it's important to also attach an error event handler, because it's possible that maybe like an HTTP request may fail, and then you want to be notified of these errors. So this is something that will be omitted here. And then what we also want to do is know when the stream is ended. So when no new bindings will be produced. So we'll just print this here. So I'll just make this a limit of 1000. So if we execute this, you should see 1000 results being printed. So these are bindings for our SPNO variables as requested in the query. Okay. Now,
sorry, Ruben, quick question.
Sure.
So to list a source from, let's say, a local trig file, is that something I can specify there with just a file colon or something?
Yes and no. So in this case, we're importing the query engine from Comunica Query Sparkle. By default, that one will not support querying over local files, just for security considerations. But you can use Comunica Query Sparkle file, and then it will be possible.
Okay. And will file work with remote URLs and files? You know what I mean? So I can add...
It will also work with remote files, but not like other types of interfaces, not Sparkle endpoints or something like that. So if you want that, you would have to create your own Comunica configuration that has the file source support and the other types of sources.
Okay, and just plug them together myself then.
Yeah.
Okay, cool.
We may actually want to also provide a preset for that combination at some point in time, because it's not that much effort to provide it.
Great, yeah, cool, thanks.
Okay, but we'll continue working with the Query Sparkle one here. Now, in this case, I just printed the bindings to the console using the .string method. So probably if you want to use these bindings in an application, you don't want to just print it to the console. You'll want to actually retrieve the values within the bindings. So for that, you can use the get method to, for example, get the value of our S variable, and the return type of this will be an RDF.js term. Now there's a lot of documentation on the Comunica and RDF.js websites for how to use these terms. But the most important thing to know here is that it has a term type field. So I'll just print this, and it also has a value field. So let me just simplify our query to have just produce one result. So if we print the result of this, you'll see that our first binding of S is just a named node, which means that the term contains a URL, and the URL is this one here. Oops. Okay, and of course you can also do this for our P variable and so on. If you want to get a bit more complex, like in the case you don't know beforehand what your variables are in your query, you can also obtain all of the keys. So this will be a list of, or an array of variables in this case. What you can also do, and this will be the last thing I show you here, is you can iterate over all of the entries within our bindings object like this. So I'll just comment this out. So you can print the key and the value like this. So if you print this output, you'll see that the key here is S, the value is our URL again, and for P and O, we also print their values. Okay, I think this was about everything I wanted to show you in the code here. Before we go over to the next part, are there any questions about this? Everything's clear. All right, great. Let me go back to the slides then. So yeah, again, all of this is available on the website as well. Maybe one more thing, if you would want to execute things like construct queries, you can use the query quads method. So again, just your query, like a construct, and then the output type will actually be a quad stream. And it can be consumed in the same way, just with that difference that the stream will not produce bindings objects, but RDF quad objects or triple objects, however you want to call them. Okay.
Sorry, Ruben, one question. What happens if you query multiple sources here on line 7? Will the two sources, will the results of the two sources be combined to one stream?
Yes, they will be combined indeed, but I have another demo for that in just a minute.
Okay, perfect.
So I'll show how all of this works in detail then.
Thank you.
So as promised, a demo about federated querying. So this is in case you would want to execute a Sparkle query over multiple sources. So as you remember in the previous slide, in the last demo, I showed you this context object that can contain a sources array. So you can basically just enter any number of sources in there that you want. But more information if it's available on the website. But I'll show you some things here, but I'll just copy paste some starting code I prepared. Just a minute. Okay. So yeah, the code I just pasted here is quite similar to the one we had before, with that difference that we now have a slightly more complex query where we basically try to find all of the topics that are mentioned in our source or sources, and we obtain the actual human readable name of this topic. And in this case, we are just querying over the Comunica website, because in this case, the Comunica website contains some RDF triples. And if we execute this query, you will see that we actually have no results. The reason for this is that the Comunica website only lists certain topics, but it does not provide a human readable name. So I can prove this to you if I wrap this pattern here in an optional block to make sure that the name is optional. And now we do get results. So the result says here that software is one of the topics mentioned on the Comunica website. So a very, very simple case here. So what do we have to do, or what can we do if we want this query to actually produce results? One thing we can do is we can change the Comunica website, but in some cases that's not a possibility. If you're not the owner of the website or the dataset yourself. An alternative, what you can do is you can just define your own additional source with some additional metadata that you can also query over. So for this demo, I'll keep it simple, and I'll just define an in-memory source with some additional triples that we will also query over. So in this case, what we'll do is we will create a new store object. We just import this from the N3 library, but this can actually be any kind of store object that implements the RDF.js source interface. So what we can do here is we can...
Excuse me, Ruben, can you explain what is the N3 library?
The N3 library is basically just I can probably click through to this. No, I can't. It's just yeah, a library with some convenience RDF tools, like it contains a parser for turtle and trig and so on, but it also contains this store object, which allows you to store RDF triples in an in-memory object. And you can also, yeah, request triples from it in an efficient way then.
Cool, thanks.
All right, so in order to add triples to this, we can use the add method. And we actually have to construct our triples using the so-called data factory, which is also something that is defined by the RDF.js specification. So in order to create a triple or a quad, we use data factory.quad. We'll just define a named node, so a URL. So let me just peek again to see what the URL was I wanted to say something about, and that's this one here. So the software URL. And then we define the predicate, and this is the FOV name predicate we want to define. Name, and then we also define the actual name. We can just call it software here, like this. So what we did here is we just created a new in-memory triple store that contains one triple, and this triple says the name of this URL is software. Okay, and what we can now just do is we can add this store to the list of sources we query over. So if I did everything well, if we execute this query now, you should see a result showing up. And indeed, we see it. So I made no mistakes, so that's great. So this says that the human readable name of software is software. Okay. So this is just a very, very simple example, of course. What you can, so this sources array is quite powerful, so you can just add any number of sources in here you want. So what you can also then do is, for example, on my personal website, I also have some RDF triples. I can just add it as a new entry in the sources array. And if we now execute the query here, you see that we have some additional results showing up in here, because I also have some topics listed on my website. So basically this federation in Comunica will try to effectively combine data across different sources, so that if a certain source says something and another source has additional information about it, Comunica will make this link and allow you to query over it as if it's one big data set. Okay, any more questions about this federation? Okay, then we can go over to the next part, which is the more advanced topics. Yes,
Ruben, sorry, just a quick question there on it's a bit like the federated Sparkle queries, which is very simplistic. But what if one of those sources gives a a 404 or something? Does it break the whole?
Yeah, that's a good question. So by default, if one of the sources breaks, so I'll just make this an invalid URL, and you will see what happens immediately. If all goes well, you will see an error. So it threw an error saying that it could not dereference the source. If you do not want this to happen, you can make use of the lenient mode. So you can, this is just an option you can use in the context. This also exists on the command line, by the way. So if we do this, if all goes well, I didn't test this before the presentation, but if all goes well, this query should still work.
Should be lenient true, I presume.
Yeah, sorry. Yeah, indeed. Yeah, so we still see the results. Now
this is like Sparkle, the service keyword in Sparkle, right? I mean, it's or the silent that, but
yeah,
it's limited, right? Because like, you know, what if I determine that maybe one of those sources is optional, maybe, but you know, if that one fails, lenient true is fine, but these other two sources are mandatory. If one of those fails, then I want the error. Do you know what I mean? It can get very complicated very quickly.
Yeah, indeed. You actually have some more fine-grained control as well. So what you can actually do, but I don't remember exactly how it's done. I think it's like this. You can expand this, like each source in the array, and you can define an additional source-specific context. But actually, I'm not sure if that's the correct syntax, but it's something like this, but it's documented on the website in any case. Wow. That you can set the lenient flag for specific sources as well. Very cool. But there are also a bunch of other options that you can also define specifically on certain sources.
Very nice. Yeah, that's cool. Okay, I like that. Thanks. Cheers, Ruben.
Okay, any more questions about the federation? Yeah, all right. Okay, let's have a look at the final part of the presentation then. So for this, I just want to discuss three, or at least give you pointers to three of the more advanced topics. So first, I'll explain to you in very high level what the architecture of Comunica is. Then I want to talk a bit about query planning. And then I also give you some pointers on alternative configurations of the Comunica query engines. So first, let's start off with the architecture. So Comunica achieves its modularity by making use of the so-called actor model, where the goal is that all of the logic inside Comunica is separated into very small actors. So the idea is that each actor can independently perform a very specific task. For example, you could have an actor that is able to parse JSON-LD documents. You could have another actor that is able to parse Turtle documents. You could have another actor that is able to execute the Sparkle union operation. But you can also have another actor that can also execute the Sparkle union operation, but does it in a slightly different way, maybe slightly more specific, more efficient in some cases. So yeah, you can have a bunch of different actors. And then, of course, you still need a way of combining these actors to solve more complex tasks. So for that, Comunica makes use of task-specific buses onto which actors can be registered. And then so-called mediators are used for selecting an actor to solve a very specific task on a bus. Okay, so this may still be a bit vague at the moment, but in general, the idea is that you have three types of components in Comunica. So you have the actors, so the things that actually execute tasks. Then you have buses onto which actors can be registered. And then you have mediators to actually select a specific actor on a certain bus. So in practice, actors will never communicate with each other directly, but they will always communicate via mediators and then buses. But let me just show you a very simple, concrete example of how these components can interact with each other. So let's assume we're in the case where we want to parse some RDF documents. And let's say we have two actors to do this parsing. We can, for example, have a fast parser, so an actor that parses as fast as possible. And then we can have another actor, a slow parser, that may, for example, parse a bit slower, but is more memory efficient. Okay, so we have these two parsing actors. These will be registered on the parsing bus. So the parsing bus will contain two actors. And on top of that, we will have a mediator. This mediator allows us to make a choice between these two actors. So what will happen in practice if we, for example, want to parse something? So we have a parsing action. This will always be sent to the mediator. And the mediator will take care of all of the internal communication to, in the end, return a parsing result based on the action we gave it. So assuming we have this parsing action, each mediator will always go through two phases. We have first a testing phase, and then we have a running phase. In the testing phase, the mediator will just try to determine what actor it has to use. So what's the most efficient actor for this specific action? And then the running phase is actually executing this action on this best actor. So what will happen exactly is in the testing phase, the original parsing action is forwarded through the parsing bus to the two actors. But the actors will not actually execute the action just yet. What they will do instead is they will just tell us the conditions under which the action can be run. So for example, the fast parser can, for example, say, okay, for this action, I think I will do it in approximately 1 millisecond, but I will require 10 megabytes of memory. Then the slow parser may, for example, say, okay, I will do it a bit slower. I will do it probably in 10 milliseconds, but I will only require 1 megabyte of memory. Okay, then these conditions are sent back via the bus to the mediator, and now the mediator has this overview of the conditions under which each actor can execute the action. And since we're using a fast mediator here, or a mediator that is configured to run as fast as possible, it just picks the first one, so the fast parser, because it has the lowest estimated execution time. And then the next phase, the running phase, is quite simple. We just call the fast parser actor immediately, so without going through the bus, and we just let it execute this parsing action, and then the response is sent back upwards. And then we're done. Okay, so basically every action internally within Comunica happens via logic similar to this one. So in practice, I'll show you an overview here. In practice, we have a lot of buses and actors inside Comunica. So this figure here shows you the most important ones. So all of these actors and buses communicate like in this way. But yeah, I won't give you too many more details about this. So as you've seen in this figure, so there are a bunch of different actors that you could make use of. In practice, you still need a way then to wire them all together in a way that makes sense. So for this, we make use of the components.js dependency injection framework. So this allows you to create simple configuration files in which you basically define the different actors that you want to use and on which buses they need to be registered, and configure the mediators. And then if you just declare these components, the dependency injection framework will actually be able to instantiate everything and create a proper query engine out of all of them. Okay, but the website contains a lot of examples of how to do this exactly, so I won't go into more details about this part. Another thing I want to mention is a so-called query plan. So for people that used other query engines before, you know that a query plan is basically a blueprint of how a query engine will execute a query. And of course, Comunica also has a query plan internally. So Comunica uses the Sparkle algebra for this, which is basically an algebraic representation of a Sparkle query string. So we use this format just like any other query engine because such a representation is just easier to work with than working directly on query strings. Now, this query plan is very important because yeah, it really has a big impact on query performance. Like if you compare like an optimized query plan with a non-optimized query plan, it can make a difference of, for example, executing within 1 millisecond versus executing within 1 hour. So having an optimized query plan is really, really important. So yeah, query planning is the task of optimizing the query plan to make sure that it runs as efficient as possible. And important to know here is that Comunica actually makes use of so-called adaptive query planning. And this means that Comunica will adapt the query plan at query time, because traditionally query engines, like centralized query engines with a centralized database, for instance, they know beforehand where all of the data is located. But because Comunica queries over web resources, it sometimes only knows about certain statistics or indexes about certain data sets while it is executing the query. So what Comunica does in practice, it will do this adaptive query planning, and it will modify the query plan if it detects some things about the data set while it's doing the query. Okay, in case you would want to see this query plan, so this is more for really advanced users, or if you want to develop something in Comunica yourself, there is an easy way of printing these query plans. Like you can, for example, do this on the command line using the explain option. And there are actually 3 different explain modes. And I'll just jump back to my console to show you this. Okay, so we just clear this. I just have to navigate to a certain directory. Where is it again? It's this one. All right, so what we have here, I prepared a very simple Sparkle query. So just a bunch of triple patterns and a filter. So what this query does here is not important now. But what we can do is we can make use of the explain mode to see how Comunica sees this query. So let me just show you different explain modes that are available. So if we print the help, you'll see this explain option here, and it says here it prints the query plan. And there are 3 explain modes available. So there is the parsed explain mode, the logical explain mode, and a physical one. So I'll go over each of them separately. So first, the parsed one. So I'll just copy paste a command execution here. So the first one, if we run, or if we retrieve the parsed, or if we explain the query in a parsed mode, then we'll see this output here. So what you see here is just the JSON representation of the Sparkle algebra. So this is how the query engine sees the Sparkle query string here as a parsed algebra tree. Then the second mode we have is the logical mode. You'll see that this is actually quite similar to the one we had before, but the output we see here is actually modified slightly already. So Comunica will actually try to do some optimization still beforehand where possible. And this here, so the logical output mode, is the already optimized form. And then probably the most interesting one is the physical explain mode. And if we execute this, you'll see that it actually takes a bit longer to execute. And the reason why it takes a bit longer is because, as I've told you, Comunica does adaptive query planning. So the query plan is actually determined at query time. So if you execute the physical explain mode, then Comunica will actually do a full Sparkle query execution in order to determine what the final query plan was. So I won't go into too much detail about this, but things you can see in here is, for example, what the type of join operation was that was used to join the different triple patterns together, and what cardinalities were found for the different triple patterns, and so on. But yeah, you can find more information about this on the website. And yeah, this is the link you can find more details at. Okay, then one final thing, just some pointers towards alternative configurations. So as I've mentioned, Comunica is the set of building blocks, and you can build your own query engine, but you can also make use of a bunch of presets that we have. Like, for example, we have Comunica Sparkle Solid that contains some building blocks next to the default Sparkle ones to be able to do authenticated requests over solid pods. Then we have also more of an experimental one for linked reversal queries, where you can actually let the query engine follow links between documents that it considers relevant for the query. Then we also have another experimental one for reasoning that allows you to query over implicit information via inference. And we also have some other ones still. And the nice thing about Comunica is that you can combine all of these together, of course. So you can also do linked reversal, combine it with solid, and maybe do some reasoning as well. So yeah, you can configure this yourself, of course. Okay. And this brings us to the end of this presentation. So I just have one more slide to summarize the most important things here. So the main goal of Comunica is to abstract away access to knowledge graphs so that it's simpler for application developers. And it does this by making use of declarative queries such as Sparkle and GraphQL. Since Comunica is implemented via JavaScript, it can run anywhere. So it can run the command line, it can run client-side in the web browser, server-side via Node.js, and so on. And yeah, because Comunica is open, anyone can use it and, of course, also contribute to it. All right, this was about everything I wanted to tell you. Are there any more questions about any of the things I just explained?
Nobody else has a question. I have a small question. We're running the Comunica web client and query a triple store with a construct query that only is available as XML. Mm-hmm. And therefore we get an error message. It cannot handle that. Is that by design, or is that some configuration that we haven't got right? Do you know that?
So you said that you want to query over XML data. Is this RDF?
No, we're querying a triple store using Sparkle, and we use a construct query to get RDF. The only thing is that the triple store returns it as an RDF XML document. Mm-hmm. And Comunica doesn't seem to be able to parse it. But maybe that's just like a configuration thing.
So Comunica should support RDF XML as well. So in theory, it should work. Yeah. But what may be the problem is, so if you, let me just go to my command line here. If you query over something like URL in Comunica, Comunica will always first try to determine what thing this is. So what type of source is behind this URL. The problem with Sparkle endpoints is that the specification does not make it mandatory to add a so-called service description to the Sparkle endpoint. So in some cases, if triple store vendors do not expose this this service description, Comunica is not able to detect that it's a Sparkle endpoint. So in that case, it may fail. But what you can do, for example, on the command line, is do something like this. So type Sparkle add before the URL, so that you basically force Comunica to see this as a Sparkle endpoint. So you can also do this in the code here. So if you have a source here, so let's assume my website here is a Sparkle endpoint, you can do type and then Sparkle to make it really be forced as a Sparkle endpoint. And then you'll basically skip this source detection or source type detection functionality, which in your case is probably the thing that breaks.
Okay, we're going to try. Thanks.
And if it doesn't work, feel free to open an issue and we'll
okay,
have a look
we
at
will. Thank you very much.
Any other questions?
Ruben, maybe just a quick one on like a roadmap question, maybe. Have you started looking at Sparkle Star and RDF Star support yet?
We start with that at some point, but then we removed it again from the roadmap because actually none of us had any practical use of it at the moment, at least. So at the moment, this is not part of the Comunica roadmap. Also because, as I've mentioned at the start here, so in the Comunica Association, we don't have any members at the moment that are in need of Sparkle Star or RDF Star.
Sure, no problem at all. I know Ontotext GraphDB has kind of support for it already today.
Yeah,
so that's what I was playing with it. But it was just an open question, really. I wasn't expecting much. That's cool.
So the basic things are there already. So actually finishing all of it up would not require too much work. And I think at some point in the future we'll probably have it, but no one is actively working on it at the moment, at least.
Yeah, sure. No, I believe the whole thing is still in discussion. I don't know where it is.
Yeah, indeed.
It's becoming standardized or anything, but yeah, no problem. Thanks.
Any other questions?
I had a more generic question about the use of Comunica. Can you tell us something about the uptake of Comunica? Do you have an idea about how many places it's already being used?
It's a difficult question to answer because we don't have so since Comunica is open source, anyone can install it themselves without having to buy it or anything. So we don't have any specific statistics on that. So the only numbers we really have are the number of users on GitHub and also the number of installations on NPM. But maybe we can quickly have a look live to see where all of that is at. So if we look for the core version of Comunica, for instance, you see that it's around 6,000 weekly downloads. And if we go to the Comunica project, to insights, and then the dependency graph. So let me just pick the core one again. Where is it now? Yeah, cannot find it, but yeah.
But maybe just
at least this amount.
Ruben, just maybe to answer that from an Inrupt perspective. So, I work for Inrupt, and we use it with every customer engagement so far, because our enterprise solid server implements a QPF endpoint. We use Comunica to demo query capability, full Sparkle query capability from the client side. So literally every one of our proof of concepts and every one of our customer engagements, we include Comunica in that.
That's interesting. Yeah.
So does it mean it will be used in the Flemish infrastructure, the solid infrastructure? It's being built in Flanders?
Yeah, also on our end, partially at least, yeah. So yeah, as you probably know, so Comunica was originally designed as a research project. So we mainly designed it for researchers, but then it ended up being also valuable for outside of research, so within actual industry. So yeah, we as a research group, we're still using Comunica for research mainly, but then of course it's also being used elsewhere. But this elsewhere, we don't have a very tangible view of where exactly. Mainly if people have questions or something, then we see who is using it for what. But other than that, we don't have a very good view on that.
And question for Indra, are they member of the Comunica Association already?
I don't know. I don't think so. It could be just logistics. There's no reason why we wouldn't be. I don't think. I'm just a developer, though. I'm not. I don't deal with the business side of things. But
It's just
absolutely. Yeah. No, absolutely no reason we wouldn't be. I could say that with confidence. Just a matter of getting logistics sorted out, I think. Yeah. I'm a techie.
Yeah, so at the moment, the Comunica Association is still in a soft launch state. So the official launch will be, probably in the second half of this year. So all of the organizations that are a member around that time will be considered like founding members, and will have like a place on the website and so on. But yeah, the official launch is something for later. Okay, any other questions?
No, perhaps a quick one, Ruben. This is your introduction talk. Will there be a future talk about even more advanced topics?
There might be, but there are no concrete plans for it yet. But yeah, if there is a need or people ask for certain things, then we can definitely consider it, but no concrete plans at the moment.
Yeah. Okay, yes, thank you.
Okay, yeah, we're running a bit late already, so I would suggest we keep it at this. If there will be any more questions, you know where to contact me. But in any case, this recording will be made public, so feel free to share it with any of your colleagues that could not be here today. All right.
Thanks. It was an excellent introduction, explanation of stuff. Thank you very much.
Thank you.
Thank you
for being here.
Thank you.
Thanks, Ruben. Great job.
See you all.